Hello. Please hit like button and subscribe my channel. Also press bell icon for future video notifications. Thanks.
Scientists have combined NASA data and cutting-edge image processing to gain new insight into the solar structures that create the Sun's flow of high-speed solar wind, detailed in new research published today in the Astrophysical Journal. This first look at relatively small features, dubbed plumelets, could help scientists understand how and why disturbances form in the solar wind. The Sun's magnetic influence stretches billions of miles, far past the orbit of Pluto and the planets, defined by a driving force, the solar wind. This constant outflow of solar material carries the Sun's magnetic field out into space, where it shapes the environments around Earth, other worlds, and in the reaches of deep space. Changes in the solar wind can create space weather effects that influence not only the planets, but also human and robotic explorers throughout the solar system, and this work suggests that relatively small, previously unexplored features close to the Sun's surface could play a crucial role in th. This shows the importance of small-scale structures and processes on the Sun for understanding the large-scale solar wind and space weather system, said Vadim Uritsky, a solar scientist at the Catholic University of America and NASA's Goddard Space Flight Center, who led the study. Like all solar material, which is made up of a type of ionized gas called plasma, the solar wind is controlled by magnetic forces. And the magnetic forces in the Sun's atmosphere are particularly complex. The solar surface is threaded through with a constantly changing combination of closed loops of magnetic field and open magnetic field lines that stretch out into the solar system. It's along these open magnetic field lines that the solar wind escapes from the Sun into space. Areas of open magnetic field on the Sun can create coronal holes, patches of relatively low density that appear as dark splotches in certain ultraviolet views of the Sun. Often, embedded within these coronal holes are geysers of solar material that stream outward from the Sun for days at a time, called plumes. These solar plumes appear bright in extreme ultraviolet views of the Sun, making them easily visible to observatories like NASA's Solar Dynamics Observatory satellite and other spacecraft and instruments. As regions of particularly dense solar material in open magnetic field, plumes play a large role in creating the high-speed solar wind, meaning that their attributes can shape the characteristics of the solar wind itself. Using high-resolution observations from NASA's Solar Dynamics Observatory satellite, or SDO, along with an image processing technique developed for this work, Uritsky and collaborators found that these plumes are actually made up of much smaller strands of material, which they call plumelets. While the entirety of the plume stretches out across about 70,000 miles in SDO's images, the width of each plumelet strand is only a few thousand miles across, ranging from around 200–300 miles at the smallest to around 400–500 miles in width for the widest plumelets observed. Though earlier work has hinted at structure within solar plumes, this is the first time scientists have observed plumelets in sharp focus. The techniques used to process the images reduced the noise in the solar images, creating a sharper view that revealed the plumelets and their subtle changes in clear detail. Their work, focused on a solar plume observed on July 2–3, 2016, shows that the plume's brightness comes almost entirely from the individual plumelets, without much additional fuzz between structures. This suggests that plumelets are more than just a feature within the larger system of a plume, but rather the building blocks of which plumes are made. People have seen structure in and at the base of plumes for a while, said Judy Carpin, one of the authors of the study and chief of the Space Weather Laboratory in the Heliophysics Science Division at NASA Goddard. But we've found that the plume itself is a bundle of these denser, flowing plumelets, which is very different from the picture of plumes we had before. They also found that the plumelets move individually, each oscillating on its own, suggesting that the small-scale behavior of these structures. Searching for plumelet signatures. The processes that create the solar wind often leave signatures in the solar wind itself, changes in the wind's speed, composition, temperature, and magnetic field that can provide clues about the underlying physics on the Sun. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.